this talk will be an introduction to microcontroller, and especially how you can start writing some code for microcontrollers, and also how you can connect your own microcontroller to the Google Cloud Platform. Before we start, I have just a simple hand-raising question for you so I can know you better. Raise your hand here if you have already developed for a microcontroller, either if it's a simple Hello World on an Arduino or ESP or others. So I can see in the room like 10 people. Congratulations, that's cool. Today we will, since not a lot of people have already started with it, we will do it from the scratch. So what is a microcontroller? Let's open the camera. A microcontroller is a simple computer located on an integrated circuit board. So one of the most famous platforms for prototyping on microcontrollers is the Arduino. So it looks like that. You see it's very small. And the microcontroller actually is the black part here, which is an Atmega 328. It's a very small computer. It has like 16 megahertz of CPU, 2 KB of RAM, so it's really, really small. So this is the computer, this is the microcontroller, and the blue board that is underneath is actually a prototyping board. A microcontroller is like a computer, so it has a CPU, it has memories, read-only and random access memories, and it also has interfaces to connect to various devices. So it's called input-output interfaces, and on an Arduino you can see you have plenty of those on those pins. So this is the most famous microcontroller platform. It's an Arduino Nano, and Chinese people, they wanted to create better, and they created this, which is an ESP8266. And this microcontroller, you can see it's the black part that is here, and you can see here that it has an antenna. So it has a Wi-Fi support, means in this computer, in this microcontroller, you can create some code that connects to the internet to send HTTP requests, for instance, or others. It's much faster, so it's like 80 megahertz of CPU, 64 KB of RAM. But you know, the Chinese, I didn't stop here because this one is good, but they created like a successor, which is even better. It's the ESP32. So this one is the ESP8266, this one is ESP32. Actually, the ESP32 is this microcontroller. So this is very cheap, very small, and inside that, you have everything required to create programs and connect to the internet. This microcontroller, I like it a lot, the ESP32, because it actually has a Bluetooth stack, so you can even create code to communicate with Bluetooth devices. And again, I bought a simple prototyping board, which is the ESP32 dev kit, which has many inputs and outputs to connect various peripherals. How you write code for a microcontroller? You have various ways to do it regarding what is your preferred way to write code. You can use a C and C++ using the Integrated Development Framework, the official one. You can use Arduino C. Arduino C is like a mix between C and Java. It's a higher level C. You can use Python, JavaScript, Lua, even Go. And you need an IDE. So today we will use Arduino C because it's really easy to create code for this microcontroller using Arduino C. And we will use the Arduino IDE, which may not be the best IDE for writing code for microcontrollers, but it's a very good way to get started. If you want something better, you can try Platform IO, which is a different IDE. Okay, so let's start Hello World. We just opened the Arduino IDE. We click on File, New, and you can see you have two methods. You have a setup method and a loop method. So actually, the setup method will be called once when your application starts, and the loop method will be called each time in a loop. So if you know main C, it's something like that. So you have your main method. The setup is called only once, and in a while true, you call your loop method. So it looks like that, but you don't have to create the main code. You just have to override those simple two signatures. So let's create a Hello World. To create a Hello World, you have to use the serial. The USB serial will connect your microcontroller to USB. It's an interface to connect to USB. So let's initial the serial interface at 96,000 baud. It's just an implementation detail. And we can just serial.println, hello Tbilisi, and we can just delay every second, so 1,000 milliseconds. We can compile our simple program. Then I will connect it to my computer. And click on the button to upload it. So now let's wait some time until. So here you can see in the bottom that it has done compiling. Let's try uploading it. It connects to the USB port, and it starts flashing your code. So here it's relatively fast because we only have 2 lines, one to set up the serial communication and one to say hello. And now if we click here to see the serial monitor, we can see hello Tbilisi every second. So you can see how quickly it is to get started writing a simple hello world. But of course, we don't want just a simple hello world. What could be interesting would be to actually connect our microcontroller to a sensor to know, for example, the current temperature. So for that, you can buy on internet some sensors. Oh, and I forgot to tell you about a little thing. A microcontroller is usually relatively cheap. So you can have the 8266 for like 5 Laris. So it's really, we are very lucky to live in a period where you can just create some code for microcontrollers for relatively cheap. And if you want a better one, it's, for instance, the one we use today, it's more expensive, but you can afford it. Okay, so now we will use a very small sensor. It's this one, which is a BME280. It's a temperature sensor, which has some wires to connect to your microcontroller. So you cannot see in detail, but here it's written how you connect it to your microcontroller. So you have 1 line for the power input, 1 line for the ground, and then you have 2 lines to connect it to your microcontroller. One is called SCL, which is a clock, and one SDA for the data. So what you do usually is you search on internet and to see how you connect it. And then it usually looks something like that. So once you have your microcontroller, you can just check a board that tells you all the inputs and outputs. And here on my microcontroller, the voltage is here, and the clock is number 22. The data is number 21. So I have to connect my little chip to the GPIO 21, 22, and these 2. So to save us some time, I already make the wiring. So once again, this is your temperature sensor. The VCC connects to the power, the ground. And then, as we said earlier, the clock is to GPIO 22, and the data is GPIO 21. It just like that, so you have to connect it like that. And if you want to see, I already did the wiring, and it looks exactly the same. So, because I actually did the same on a breadboard. Okay, so I connected my microcontroller to a simple temperature and humidity sensor. So how you access those data using the Arduino IDE? So in the Arduino IDE, you have to use tools and manage libraries. Libraries, you may be familiar with that. It's some interfaces to give you some implementation details to connect to various different things, whether an API or this board. So I just manage library, and I install a library compatible with my BME280. So I just install one. And then on the Arduino IDE, you can just file examples, and you can find some examples on how to use your sensor. So once you have installed the library, it tells you how to use it. So how to use this one, you have a simple import. Then you have to have an instance of your sensor. In the setup method, we will initialize the sensor. So we will try to call bme.begin, and if it fails, we will just write a very simple message. And then in the loop method, we have just a method to get the temperature, which is bme.readTemperature, and we will also get the humidity. And all that once every second. So we will try to save it and to import it. So once again, to access different peripherals, it's usually easy. It's just one line to set it up, and then some lines in your loop method to access it. So here it's connecting to the board, and it starts flashing the code to the microcontroller platform. And after, when we open the serial line, we should see every second the temperature and the humidity. So it works. And you see how easy it is to connect to various peripherals. But we are not done yet. We have those data locally. It would be good to send those data to the cloud. So you can either create your own server. For instance, you can host your own server on a Dockerized Raspberry Pi inside your home and send data to this server, or you can just have a server in the cloud. But you can also use Google Cloud Platform to have a more secure and scalable way to have a cloud platform, to run code on the internet. And a good thing with Google Cloud is you have a service which is called Cloud IoT Core. Cloud IoT Core is a service that helps you to securely connect and manage and ingest data from every devices. So you can take any devices, whether it's a microcontroller unit or an Android phone or a computer, and Cloud IoT Core helps you to connect that peripheral to the Google Cloud in a very standard way. How it works, it provides two interfaces, an HTTP gateway or an MQTT gateway. You are familiar with HTTP, it's a standard protocol for the internet. You can just send queries, HTTP requests. You may be familiar with GET, POST request, stuff like that. MQTT is very lightweight. It's usually a protocol for microcontrollers to send very small messages, very small events. So both are two standard protocols. So now how we can connect a computer or a microcontroller to the Google Cloud. Let's check it. So first, Cloud IoT Core is a secure service, which means you have to generate keys. Generate keys, you just can use OpenSSL for that. You just generate an asymmetrical key pairs, like you have private keys and public keys. Here I use elliptic curve, but you can use RSA if you prefer. So I just generate some keys. Here I have my public key and my private key. I will just go to the Google Cloud Developer Console. I will go to Cloud IoT Core. And then I will select a bucket. A bucket is a registry. A registry is like a bucket of devices. It's a bunch of all your devices. If you want to create your own temperature sensor and sell it to the world, you can just create a registry called the temperature sensor, for instance. And in this bucket of devices, you have to create a device. So I will create a device which is, I name it ESP32. I will use elliptic curve as my asymmetrical key pairs, and I will just copy my public key and provide it to Google Cloud. So now Google Cloud is aware that I have a device, and it knows this public key. So my device will try to communicate with this with Google Cloud with its private key, and if the private key matches the public key, it means it's secure. So how to connect to the Google Cloud Platform? First, you have to generate a JWT token. A JWT token is a JSON Web Token. It's another standard on the internet. It looks like a JSON. So you have your token. You specified the input, the issued at, so when your token was generated, when it will expire in 1 hour, and your Google Cloud Project ID. So you create a JSON token. You sign it with your private key. You can see here I wrote a very small Python code, but you can use Arduino C, you can use whatever language you want. So I will just generate a JSON Web Token. I have my JSON Web Token here, and I will use the HTTP bridge. So first I specify my JSON Web Token. I write a message, for instance, hello Tbilisi. I have my project ID, my region, my registry, and my device. Those are information from Google Cloud. So my project ID is IoT Core-project, which is here. I'm in Europe West 1. My bucket of device, I name it IoT Core Registry, and my device, I name it earlier ESP32. And then it's just a simple POST request. So if you want to send data to the cloud, to the Google Cloud Platform, you just have to use a simple HTTP POST request. I used curl here, but you can use any HTTP client. You just specify your JWT in the authorization header, and then the data base 64 signed at this given URL. And usually, if you do that, it should send the message to the Google Cloud Platform. And now if we try to query Google Cloud PubSub, so Google Cloud PubSub, I want all my message, I should be able to see my message right now. So Cloud IoT Core is a gateway. It uses HTTP or MQTT gateways, industry standard of the internet, and it directs those to Google Cloud PubSub. So here you can see that it works. In a very simple HTTP request, I just connected my microcontroller to the cloud platform, and I can send data to the Google Cloud. You can use HTTP, but you can also use MQTT. We will not try the example here, but it's the same. You have your message, and you use an MQTT client. For instance, here I use Mosquito, which is an implementation of MQTT for desktop, which works really well. And you just specify some specific information to connect your computer to the Google Cloud. So you can see how easy it is. Now let's use Arduino to do the same. So to save us some time again, I already wrote the implementation. I will just compile it first, and then I will explain to you in details what I did. So first, I told you it's secure. So we need to get the private key to generate a JSON Web Token. So we will go back to where our private key was generated here, and we can just specify that private key to our project. So this is our private key. We will just place it here. We will try to compile it, and if it works, we will see the implementation. So we compile it. Again, I told you on the Arduino IDE, you have many various libraries to do a lot of things. And you have a library that helps you to generate a JSON Web Token for you. So you just have to specify the private key here. It will generate a JSON Web Token. It will sign it. And this library will also use an MQTT client to connect to the Google Cloud Platform. So you can just find, again, examples. So you just click on File, Example. You check this library, which is called Google Cloud IoT Core JWT. So first, let's try to flash it. OK, it's flashing. So what I did is, remember my project from earlier? I just, once again, imported a header. So this header to connect to MQTT implementation. In the setup method, you just have to call setup cloud IoT. Setup cloud IoT actually will set up an MQTT client, will generate your JSON Web Token, and will give all this information. So you just have one line in the setup call, a few lines in the loop method. Those lines are just to keep the connection with MQTT. So if you use Arduino and MQTT, it's usually like that. In the loop method, you keep the connection with MQTT. And then if you are not connected, you just connect. And now, every 5 seconds, what I will do is I just take my payload. So remember the method earlier, BME.read temperature and read humidity. I just put those in a JSON. And I will just call this method, publish telemetry, to send this payload to the Google Cloud. So what it does, if we check the implementation, it calls the publish telemetry method from the MQTT client. So if you want to connect a microcontroller to the Google Cloud, you just have one import, one line to set up everything, and of course, one line to publish message to the Google Cloud Platform. So now let's try to see. And you can see here it's sending temperature and humidity data every 5 seconds. So now data is in the Google Cloud Platform. It's in PubSub. So what you can do is you can do whatever you like, because Google Cloud Platform is very scalable. You can create a cloud function, for instance, that listens to PubSub. And every time a message is sent to PubSub, it can forward that message, for instance, to a Cloud Firestore. So it's what I did. I have set up a Firebase project, a Cloud Firestore project. And in my database, my cloud function, I wrote a simple cloud function that will publish messages into Cloud Firestore every 5 seconds. So you can see some new entries every 5 seconds. And if we click on one, it's what my microcontroller here sent to the Google Cloud Platform using the simple lines of code you saw earlier. And now data is in PubSub. You can just save it to Firebase. So for instance, you can create a very simple hosting page using Firebase hosting to host a very simple static web page on the internet. So here I have my, the current temperature in real time. And if I press on the microcontroller, you can see that it raises. So it means it works and it's in real time. But we can go a little, we can do better things. So data is in PubSub, so you can really do whatever you want. It's in Firebase. So if I want to have fun, I can just do a lot of different things. I can just for instance, we are humans, and we have data in our body, and it could be interesting to send this data to the cloud, because actually we are humans, but we are just some more things with some humanity. So what we could do is we can connect our own body to the Google Cloud platform very easily using the same way. So here in Google Cloud, what I did is I hosted a simple Grafana on Kubernetes. So if I go to my Kubernetes engine, I should be able to see a Grafana. Yeah, connected to a simple time serial database. So my microcontroller on my body is sending data to the Google Cloud to know, for instance, my heart rate. Cloud Function is saving this data to an InfluxDB time serial database, and I should be able to access my data in real time. So here, during this presentation, you can see that I was really stressed, and my heart beats like at 160. Usually it's like 80 BPM a minute when you, 80 BPM a minute when you are usually okay. I was very stressed in front of you, so this is before the talk starts. And when the talk starts, I was like, come on, what am I doing with my life? So you can just connect your any kind of devices, whether it's a Raspberry Pi, an Android device, a microcontroller, or your own body to the Google Cloud platform. If you want more information on how I connect my body to the Google Cloud platform, I cheated a little. I created a very simple Node.js application with Bluetooth low energy web APIs to get my heart rate from a Bluetooth sensor I'm wearing currently, and it sends those data using a Node.js application to the Google Cloud the same way you could do it either with a computer or a microcontroller. Why create code for a microcontroller? Because now in this, right now currently, we can just create every device from scratch. So we are very lucky because a microcontroller is very cheap. But then what you can do with your microcontroller, so you can just created this, but you can see this is like ugly. If you want to do something more professional, what you can do, so here I'm using Freezing. It's just some drag and drops. You connect your microcontrollers and stuff, and you can see you have a PCB tab, and this PCB tabs helps you to generate a PCB. So you can just generate a PCB, then you can click on the export button. It will generate a zip file, and you can upload it to any kind of PCB printing platforms. It's like 10 Larrys or something like that to print your own PCB, so it's affordable. And I wrote a simple PCB right now, the one you could see, and then I receive it a few weeks later, and it looks like that. So you can see that it's really good quality. It's very cheap, and then you can just put your PCB, connect your microcontroller, connect your sensor, so you can see it's more professional, and then you can use 3D printing services to print some boxes. So here I use an online 3D print service to create a case, so I can just place it here like that. I put the cover. It's not very expensive. And now I have my box. I place it in my home. And you can just have your box like that. So now we live in an era where we can just create a finalized product from scratch. You can just write code from your microcontroller, create the PCB, create create the 3D printed case, you can just create a full device from scratch, and it's affordable. A few years ago, it used to be thousands of dollars or something like that. Now every one of you can do it and create your own devices. So it's really a lot of fun now. So I just wanted to take some time of the question to show you that. But once again, we have one-on-ones for questions. Thank you very much.